In a metal base roof, as we can see in the picture, it's a different technique altogether. We need to hold the entire structure and panels onto the roof. Please keep in mind that the winds might be very, very strong and they're coming from different directions. And a panel is basically like a sail. It receives wind coming toward it. Not only that it receives the wind, but having the situation where the wind is coming from different direction, and we have many rows of panels, the entire system vibrates. And in the other end, in the backside of the rows of panels, there's almost no wind coming from a sailing point of view, coming and hitting the front of the panel, but there is a wind which is flowing through that underneath tunnel. That tunnel, which is under the modules, wind flows through it. The speed of the wind is very fast because the wind is in a tunnel, which causes a low air pressure, causing that there is a high pressure on the front of the panel, low pressure on the back of the panel. And this is randomly occurring, meaning the entire structure together with the panels will vibrate. Tremendous forces are being applied to a big sail like in the picture. This is why we have to hold the entire structure on that metal roof, but we don't hold it to the roof itself, because the roof itself is a very thin layer of metal, maybe 0.5 millimeter thickness. Under this layer or plate of 0.5 millimeter galvanized metallic material, there are rods. So the entire structure is connected to the rods that hold the roof. So it goes through the roofing to the roads, meaning that it makes holes in the plate. Meaning that what's underneath that plate, this metallic plate, is not hermetically sealed anymore, because there are many, many, many holes. There are ways, and we'll talk about it in a future session where we'll deal with engineering aspects of structures, how to seal the holes, hundreds of holes that we're making in the roof in order to attach, mechanically connect that structure to the roads, the frame. I want to put your attention to what is called diagonal supports. We will talk in depth later in this session about diagonal supports, but this diagonal frame that we see in the picture provide a solution to the vibrations. So the entire system will not move right and back.